Hello viewers, welcome to my channel. I'm Hasham Ali Khan. In this video, I'm going to explain you the theory regarding measure of central tendency. This is the first practical topic in business statistics. So I'm going to explain you the meaning of the term measure of central tendency, measure of averages, why we calculate the average, what are the objectives, what are the limitations, what are the characteristics of good average, and what are the different types of averages. So after watching this video, definitely you can be able to write the theory question in examination if it is asked. Not only that, you can be able to solve the problem if you are conceptually clear regarding the concepts. So watch the video till the end, particularly to write the theory question in the examination. This is very important. It's a short video, only basic points I'm going to explain you. First of all, meaning of measure of central tendency. Measure of central tendency is also called measure of averages. So the question arises, what do you mean by average? An average is a single value which represent a mass of data. So we have collected statistically data, huge data is there. We cannot come to the conclusion. We cannot derive the conclusion by having mass of data. So we will select a single value which represent the mass of data. That single value is called average. Simple example I'll give you. A cricket batsman. He has played nearly 20 matches. 20 cricket matches he has played. In every match he has scored a certain number of runs. So first match he scored 35 runs, second match 45, 50, 30, 10, 40. Like that, individually he has scored different runs in different matches. So we cannot judge, we cannot come to the conclusion what is the caliber of this batsman. Can we be able to select him or not? So if we calculate the average score of all the matches, we can be able to judge easily. For example, we have added all the scores and divided by number of matches. We get the single value. Now suppose the single value we got 45. In other words, we can say the average score of this batsman is 45. 45 is the representative of all the individual values. This is the average. Average plays a very important role in our life. In many cases, we depend on averages. We calculate average and we take the decision on the basis of average. Another example I'll give you, a student. A student is having 6 subjects in his curriculum. He got different marks in different subjects. So we cannot come to the conclusion, shall we give first division to this student or second or third division? So we will calculate an average. We add up all the marks in 6 subjects, divided by 6, we'll get a single value, that is average. On the basis of average, we can be able to give him the decision. So this is the average. An average is a single value around which the other values will surround. That means the other values are cluttered around that single value. That is called average. It's a representative of mass of data. This is the meaning of the term average. Now, objectives and uses of average. Why we calculate average? What are the uses? The first one, it is a representative. Instead of studying all the complete data, single value if we calculate, it's representative. This single value is representing the mass of data. So it is showing the characteristics of mass of data. Simple example, just now I have given 45 runs is the average score of the batsman. So this 45 is representing all the runs he scored in different matches. Next one, facilitate comparison. By calculating this average, we can be easily able to compare the performance of two groups, the performance or the nature of two different groups, two different populations. So comparison is very easy. Simple example, 2 batsmen. We want to select any one of the batsmen, A batsman, B batsman. We are calculating the average. The average performance by A batsman, the average performance of B batsman. By comparing the average, we can be able to judge which batsman is better. Then describe the data. We can get a lot of information by calculating the average. Example, Suppose a student's average marks is, let it be 35 marks out of 100. So we can come to the conclusion that these 35 marks are very low because the maximum marks are 100. So average will describe the complete data. Next one, quantify relationship. If you want to relate two items, we can quantify in terms of average and come to the conclusion. Simple example, we calculate the average income of an American and average income of an Indian. So normally average income of an American is much more than the average income of an Indian. So how we have calculated? We have calculated the average income of Indian and average income of American. So we can quantify the data. Next one is basis for further analysis. See here, this measure of central tendency or measure of our averages is the base of all further calculations. That means the other techniques like standard deviation, skewness or correlation, regression, all these other techniques, statistical techniques, depends on this average. Only after calculating average we can be able to further make analysis, further statistical analysis is possible. So these are the objectives of calculating the average. Next comes limitation. Don't think that average will have only advantages, only uses. There are some limitations of averages. The first limitation is misleading conclusion. When we take a single value, the single value may not be representative. Simple example I'll give you. Suppose in a particular area, the extreme weather is, it is going to a maximum of 55 degrees, 50 degrees. 50 degrees temperature, whereas minimum temperature in that area is, let it be 2 degrees. 2 degrees is minimum, maximum is 50 degrees. So extreme weather is there in that area. Suppose if we calculate the maximum and minimum average, so 50 plus 2 divided by 2. So 52 divided by 2. 52 divided by 2, you are getting, suppose 25.5. Or let it be 26. 26 degrees is the average. So we will take a decision, 26 degrees is normal temperature, we can go. Suppose if we go there, suddenly the temperature is 50 degrees. What will happen? Our average is misleading. Suppose the temperature actually comes down to 2 degrees. We have misled. Because we have calculated the average 26, we are dependent on 26. It is wrong. So sometimes the average will be misleading. We cannot rely on averages. Choice of averages. There are many methods of calculating average, not a single method. Every method will have their own advantages and limitations. So there is no perfect method of calculating average. Many methods are there. We have to select which is suitable for us for our study. Then incomplete picture. Sometimes average will not disclose the entire picture of the data. Entire picture of the data. For example, the batsman. We have seen that the batsman average score is 45 runs. But in that 45 runs, in that individual score, there are extreme values like 0 run and 150 runs. That means the batsman is risky. We observed that 45 is the average, but minimum is 0, maximum is 150. The extreme values are very far away from the average. So this batsman is very risky. So it is not showing the complete picture of the data. It is only showing a single figure. That's it. So that's why we cannot rely it. So these are the limitations. Now characteristics of good average. How to find out which is the good average? Many averages are there. We have to select anyone. So which average we will select? Some characteristic features we have to see. The first characteristic feature, rigidly defined. There should not be any confusion regarding the meaning of the term average. It should not be misleading. The definition, the meaning of the average should be rigid, should be clear. It should not have any 2-3 meanings. It should not lead to confusion, misleading. It should be exact. Then second one, easy to calculate. The calculation of average should be as easy as possible. It should not be tough. Then should be based on all observation. Nothing should be left while calculating average. Each and every element should be considered while calculating the average. Next one, should not be affected by extreme values. The average should not get affected by the extreme values. Extreme values means highest value or the lowest value. Last one, capable of further algebraic treatment. The average should be such that this can be used for further algebraic applications, further analysis. Like the average can be used for other statistical technique like standard deviation, skewness, kurtosis, or correlation, regression. Other statistical analysis also this average can be used. Capable should be used. So these are the characteristics feature which good average must have. So I have explained you what is the meaning of the term central tendency, what are averages, what are the objectives, what are the limitations, and what are the characteristics of good average. Now I am going to tell you about types of averages. There are many types of averages, but the most commonly used averages are arithmetic mean, median, mode, geometric mean, harmonic mean. These 5 are the most commonly used averages apart from so many other averages. So one by one I am going to explain you. So arithmetic mean, first of all, the most commonly used average is arithmetic mean. So how to find out arithmetic mean? Take the total of all the values divided by number of values. Example, simple example, the same example, a cricket batsman. He has played 10 matches. In each match, he has scored a certain number of runs. Example, 30 runs, 25 runs, 35, 85, and 105. Like that 10 matches, 10 figures we have. We calculate the total of all the runs scored in 10 matches. Suppose the score of all the 10 matches comes to 450. So 450 runs he has scored in the 10 matches. So 450 divided by 10, you will get 45. 45 is the average, that is arithmetic mean. That is called arithmetic mean. Take the total of all the values divided by number of values. That's it. And this is the most commonly used average compared to other types of averages. Most commonly used because its merits are more than demerits. The merits are easily, first of all, the definition is very rigid. There are no two meaning of his definition. Rigidly defined, first advantage. Easy to calculate. Very easily we can calculate. It considers all the items of the data. Like that, so many advantages are. Now, how to calculate arithmetic mean? First, individual series. There are 3 types of series. Individual series, discrete series, and continuous series. When we can call it as individual, in the next video I am going to explain you regarding individual series, discrete series, and continuous series. So individual series, the formula is x bar. This is a symbol for mean. Mean is equal to summation x by n. Summation x by n. Discrete series, x bar is equal to summation fx by n. Continuous series, x bar is equal to summation fm by n. So these are the formulas we will apply. So I suggest you to go to the playlist of my channel, select the subject business statistics 1. In that, select the subject, select the topic, select the video, measure of central tendency or calculation of mean, problems on mean, problems on arithmetic mean. Select that video, solve the problem, see the solution, how I have explained, how I have solved the problems, then you will get the command on calculating the arithmetic mean, applying this formula. Combined mean. When we have 2 or more than 2 groups, then we can calculate the combined mean. Example, 2 classes are there, class A, class B. In class A 30 students, in class B 20 students. We want to find out the average marks of combined all the 2 classes. First class 30 students, second class 20 students. 30 students average will calculate the mean of the 30 students. Here we calculate the mean of 20 students. So we have 2 groups. First group, 30 is the number of student and let it be 50 is the mean. Second group, 20 is the number of students and 60 is the mean. So 2 number of values and 2 means we have. Now we want the combined mean. The formula for combined mean is x bar 1 2 is equal to n1 x bar 1 plus n2 x bar 2 divided by n1 plus n2. That's all. Again, you can find all the problems in the video which I have given on problems on arithmetic mean. Now, second, median. Median is the value which divides the series into 2 equal parts. Which divides the complete data into 2 equal parts. That is median. In other words, median is the central value of which equal number of items are there on left side and right side. So it's a positional average. The median is called a positional average because it is exactly center. So in other words, median divides the series into two equal parts. It's the central value that is called median. So before calculating the median, first you have to arrange the data either in ascending order or in descending order. After arranging, you can calculate median. So again, apart from median, we have quartiles, decile, percentile. Median will divide the data into two equal parts. Quartile will divide the data into four equal parts. And decile will divide the data into 10 equal parts. And percentile will divide the data into 100 equal parts. All the four are positional averages. So here 2 parts median, 4 parts by quartiles, 10 parts by decile, 100 parts by percentile. Procedure of calculating median, quartile, percentile, decile is same, right? So here I will explain you about the decile, median and quartiles. Similar calculations we have to apply for decile and percentile. You can see the video of problems on median. Definitely you can be able to solve the problem on that one. Now calculation of median, quartiles and percentiles. Individual series. If individual series is there, median is equal to size of n plus 1 by 2. N means number of items. How many items are there? Suppose 10 items are there. 10 plus 1 divided by 2. 9 items are there. 9 plus 1 divided by 2. That position will give you median. Then lower quartile Q1. There are two quartiles, Q1 and Q3. Q1 is the lower quartile and Q3 is the upper quartile. So Q1 lower quartile size of n plus 1 by 4. Here denominator you have taken 2, median, quartile you have to take denominator 4. And upper quartile Q3 size of 3 into n plus 1 by 4. 3 into n plus 1 by 4. Discrete series. If the data is not individual but discrete series, then median is equal to size of n plus 1 by 2. In this cumulative frequency we calculate and we find out size of n plus 1 by 2 and locate in which column of CF the value is exactly this one or next higher to this one. Corresponding value of x will give you median. Similar is the case for Q1, size of n plus 1 by 4. Q3 is equal to size of 3 into n plus 1 by 4. Then continuous series. In continuous series, first of all, we have to find out what is the median class. After calculating median class, apply the formula L plus n by 2 minus CF by F into I. If it is Q1, simply instead of 2, we will take 4. For Q3, it is 3n by 4. So these are the formulas for calculating quartiles. So here I am not going in depth into the formulas. For this, you have to go to the video of median. So go to the video of median, calculation of median. There you can be able to see my lecture on calculation of median. Now mode. This is the third third type of average. Mode is that value which repeats more number of times in a given data. Any value which is repeating more number of times, that value is called mode. A value which occurs more number of times in the given data, that is mode. Now individual series by inspection. If the data given in the problem is individual series, by inspection we can find out which item is repeating more number of times, that is mode. For discrete series, by inspection we can find out which value of x is having the highest frequency. Discrete series we have two columns, x column and frequency column. Find out what is the highest frequency. Against that highest frequency, what is the value of x? That x value is the mode value. But the mode value will be affected by neighboring items. So it is better to prepare grouping and analysis table and find out the mode in case of discrete series. In continuous series also, we have to find out the model value, model class. So for calculating model class, by inspection or by making grouping and analysis table, we find out the model class. After finding out model class, apply the formula mode is equal to L plus delta 1 divided by delta 1 plus delta 2 into I. Over. This is mode. Now geometric mean. The definition or meaning of geometric mean is it is the nth root of the product of n items. nth root of the product of n items. Example, we have two items A and B. Only two items. We want to find out the arithmetic mean of two items. So multiply A into B under root. Finish. Geometric mean. Only two items. If three items are there, A, B, C, A into B into C, three root or A into B into C to the power of 1 by 3. This is geometric mean. But if the number of 4, 5, 6, it will be difficult. So that's why we'll make use logarithm table in order to find out geometric mean. The formula is individual series GM is equal to anti-log. L stands for anti-log. Summation log x by n. Or discrete series anti-log summation f log x by n. And continuous series anti-log summation f log m by n. So if you want the command on this geometric mean, again I suggest you to go to the playlist to select the subject Business Statistics 1. In that problems on geometric mean, you can get all the problems. Next one, harmonic mean. This is the last average I am going to explain you. Harmonic mean is the reciprocal of arithmetic mean of the reciprocal of individual values. Reciprocal means opposite, inverse. For example, 5. The reciprocal of 5 is 1 by 5. The reciprocal of 8 is 1 by 8. The reciprocal of 10 is 1 by 10. So what is the formula of arithmetic mean? Summation x by n. Here I have explained you. The formula for arithmetic mean is summation x by n. Now reciprocal of this formula is n divided by summation x. Reciprocal is n divided by summation x. Now the harmonic mean says it's the reciprocal of arithmetic mean of reciprocal of individual values. So first we have to calculate reciprocal of individual values. Suppose individual values are 5, 8, 9, 10 like that. So first we calculate reciprocal 1 by 5, 1 by 9, 1 by 10, 1 by 12. Reciprocal we have calculated. Now take the total reciprocal summation 1 by x. Summation 1 by x. Now apply the formula harmonic mean n divided by summation 1 by x. The formula of individual series harmonic mean n divided by summation 1 by x. And discrete series harmonic mean n divided by summation f into 1 by x. And continuous series same formula harmonic mean n divided by summation 1 by m. That's it. So this is the explanation regarding measure of central tendency. So this lecture will be very much helpful to understand the concept. You can write the theory question in examination, and also the conceptual clarity will be there while solving the problem. We'll continue in the next video. If you like the video, if you are satisfied with this lecture, give a like to the video, give your comments, share it in your group, and subscribe my channel if you have not yet subscribed.